Today we will discuss some more problems in trigonometry. First exercise, that is, the minute hand of a watch is 1.5 centimeters long. How far does its tip moves in 40 minutes? So if you consider a circle, this is minute hand whose length is 1.5 centimeters. In 60 minutes, minutes hand makes one revolution. It makes one revolution. In 40 minutes, it makes how many revolutions? Is equal to 40 by 60, 2 by 3. If you convert in angles, theta is equal to 2 by 3 into 2 pi radians, that is 4 pi by 3 radians. Now, how far does it move? He is asked. So, if you consider this is not L, R, notation R, radius of the circle. Minute hand's length as radius of the circle R. L is equal to R theta. R means 1.5, 4 pi by 3. That is 2 pi centimeters. Pi means 22 by 7. That is equal to 3.14 centimeters. Total 6.28 centimeters distance. Again I will explain you. The minute hand of a watch, this is watch, this is minute hand, its length 1.5. If you consider as a circle, R is equal to 1.5. How far does its tip? This tip moves in 40 minutes. In 60 minutes, it makes one revolution. In 40 minutes, it makes how many revolutions? That is equal to 40 by 60, 2 by 3. Theta is equal to 2 by 3 into 2 pi radians. So 4 pi by 3 radians. Length L is equal to R theta, 1.5 into 4 pi by 3, 2 pi centimeters. So 2 into pi means 22 by 7, that is 3.14. Total it is equal to 6.28 centimeters. There is another problem. That is, if two circles of same arc length subtends angles (60°, 75°) at the center. Find the ratio of their radii. There are two circles of same arc length, septants. One makes an angle 60 degrees, another makes an angle 75 degrees at its center. Arc length is same, L is same. What is the ratio of their radii? Suppose it is R1, it is R2, R1 by R2 he is asking. Now, theta is equal to 60 degrees means 60 into pi by 3, pi by 180. So, that is pi by 3 radians. L is equal to R1 theta. R1 is equal to L by theta, L by pi by 3, 3L by pi. This is first circle. What is second one? Theta 75 degrees. 75 into pi by 180, 15. 15 5 75 by 15 12, 5 pi by 12 radians. Now, second one, L is equal to R2 theta. R2 L by theta, L by 5 pi by 12, that is 12 L by 5 pi. Now he is asking ratio R1 by R2. R1 3L by pi by R2 means reverse, 5 pi by 12L. L cancels, pi cancels, 3 4 times. That is you will get 5 pi, 15 pi, not 5 pi. You will get 5 by 4. Therefore, R1 is to R2 is equal to 5 is to 4. This is another problem. These are enough for intermediate examinations. Now, we will learn about trigonometric ratios. The next one is trigonometric ratios. Trigonometric ratios. To learn about the trigonometric ratios, first of all, we have to know about right angle triangle. Consider right angle triangle. This is 90 degrees. If you consider theta here, It is called opposite side. It is called adjacent side. The side opposite to 90 degrees is always called as hypotenuse. If theta changes, here this is 90, then it is called opposite side, it is called adjacent side, it is called hypotenuse. Depending upon theta, opposite side and the adjacent side changes, but hypotenuse does not alter because opposite 90 degrees opposite side is hypotenuse. Now you have to use Pythagoras theorem also here. That is, side square plus side square is equal to hypotenuse square. This is Pythagoras theorem. It is more useful in trigonometric ratios. It plays key role. Now, first, what are trigonometric ratios? They are sin theta, first one. S-I-N-E, sin. But we write down as sin S-I-N theta. Formula opposite side by hypotenuse. Second one is cosine, co-brother-in-law, like that, cosine theta. But we will write down it as cos theta. Adjacent side by hypotenuse. Next one, tangent theta. But we write it as tan theta, opposite side by adjacent side. Opposite side by adjacent side. The another formula is sin theta by cos theta. The next one is cotangent theta. We write this one as cot theta, adjacent side by opposite side, cos theta by sin theta. Next one, cosecant theta. We write this one as cosec theta, that is hypotenuse by opposite side, that is 1 by sine theta, inverse of sine. Next one is secant theta. We write this as sec theta, that is hypotenuse by adjacent side, that is 1 by cos theta. The last one I want to write here, cotangent theta. That is cot theta. This is opposite to tan, adjacent side by opposite side. The another formula, cos theta by sin theta. This is equal to 1 by tan theta. These are called trigonometric ratios. Sin theta, cos theta, tan theta, cot theta, cosecant theta, secant theta. Cotangent already I have written here, no necessity here. These are called trigonometric ratios. Some more formulas you have to learn. That is sin theta into cosecant theta is equal to 1. Cos theta into secant theta is equal to 1. Tan theta into cot theta is equal to 1. Because if you know the relations, it is easy to solve the problems. Some more formulas are there. That is sin square theta plus cos square theta is equal to 1. This is main formula. This is main formula. Sin square theta plus cos square theta is equal to 1. Sin square theta is equal to 1 minus cos square theta. You can write down this as 1 minus cos theta into 1 plus cos theta. Next one, cos square theta is equal to 1 minus sin square theta. You can write this as 1 minus sin theta into 1 plus sin theta. So, main formula is sin square theta plus cos square theta is equal to 1. That is main. Next one. One plus tan square theta is equal to secant square theta. Tan square theta can be written as secant square theta minus 1. Secant square theta minus tan square theta is equal to 1. From this, secant theta minus tan theta into secant theta plus tan theta is equal to 1. Because a square minus b square can be written as a minus b into a plus b. From this, you can use secant theta minus tan theta as 1 by secant theta plus tan theta and secant theta plus tan theta as 1 by secant theta minus tan theta. These two formulas play key role in solving some trigonometric problems. These two formulas are more important. These two. Main formula 1 plus tan square theta is equal to secant square theta. But from this formula, you can draw all these formulas. These two are more important in solving some trigonometric problems. The last one is 1 plus cot square theta is equal to cosecant square theta. One plus cot square theta is equal to cosecant square theta. From this, cot square theta is equal to cosecant square theta minus 1. Cot square theta is equal to cosecant square theta minus 1. Cosecant square theta minus cot square theta is equal to 1. This can be written as cosecant theta minus cot theta into cosecant theta plus cot theta is equal to 1. From this you can write down cosecant theta minus cot theta is equal to 1 by cosecant theta plus cot theta cosecant theta plus cot theta is equal to 1 by cosecant theta minus cot theta. These two play key role in solving some trigonometric problems. Main formulas: sin square theta plus cos square theta 1 plus tan square theta secant square theta 1 plus cot square theta cosecant square theta. These are all drawn formulas from those three main formulas. I think you learned in SSA, because in the new textbook he is not given all these formulas, just he is simply given the problems only. Tomorrow we can discuss some more formulas. After that we can start the second exercise. Thank you. One.